is going to 0, right? These are getting smaller and smaller. These are getting smaller. They're headed to 0. This sequence, the sequence 1 over n is going to 0. There's nobody here who's arguing against that. But that's not what I'm asking you. I'm asking you, what is the sum of all of those adding up to be? Is that headed to a number or is that infinite? That's the question. What do y'all think? What do you think? You think it's still going to infinity? So they're getting small, but you're saying not fast enough. What do y'all think? You think it's small?
Identical to the filling the cup.
Yeah, this is the filling the cup problem, all right?
I forgot how to do that.
Yeah, so this is a question I can't answer right. Well, I can tell you the answer. The answer is that this does diverge. This becomes infinitely big, but let's not get into why yet, all right? Look at this one right here, 1 over n cubed. 1, 1/8, 1/27, 1/64, right? Those are getting smaller. Those are headed to 0. That's not what I'm asking, though. What is the sum of those adding up to be? They're smaller and smaller, but we keep adding more and more and more forever. So does that become infinite or does it converge, right? So these are open questions, all right? These are open questions. This is what the goal of this section is, to try and figure out what's happening here. So this was a way that we could visualize all this. All right, so let me try and explain what's going on here. So the black dots here are the sequence, all right? The sequence. So right now we're looking at 1 over n here, right? So what happens when you plug in 1? You get 1. What happens when you plug in 2? You get a half. 3, a third. 4, a fourth, right? So what I'm going to do now is I'm going to create a new sequence, all right? I'm going to create a new sequence. Let me write this sequence out. This sequence is the sequence 1, 1/2, 1/3, 1/4, right? That's the sequence. I'm going to create a new sequence that looks like this. The first number in this new sequence is just the first number here, okay? The second number here is these two added up. What's 1 plus a half? 3 halves. Okay, I'll do 3 halves. The next number here is the first 3 added up. You quit? You quit now? What is it? 11. What are you adding? 11/6. Okay, thank you. It's 11/6. Don't worry about it. That's what it is, okay? Do you understand what I'm doing, though? The next number here is going to be the first 4 added up, and so on and so forth. Right? This is a new sequence, isn't it? Yeah. I started with this sequence. It's not this sequence. It's you're starting to sum up the pieces of this sequence. That's going to be the blue one you see down here. All right? So look at this. We already knew that the original sequence, that this sequence went to 0, right? And now when I start adding these up, each time I go out, I keep adding. I want to know what's happening to this sequence. What does it look like is happening? You think it's getting bigger? Is it getting, it's asymptotic maybe? Okay, let me give you some more points. This is only the first 10. Let me give you the first 100 points. Look at the so far, if you take the first 100 of these, they only add up to be 5.18738. Okay? The first 100 of them. But look at the pattern here. Does that look asymptotic or not? I think it's subjective. I think it's subjective. Let me go the first 400 points. How about that? Keep an eye on this number, keep an eye on this graph. The points are getting a little too big. I'm making them smaller. It didn't get much bigger, right? But does it look asymptotic to you? Let's go 1,200 points. I might bring my computer to its knees here. Look at that. The first, oh, yeah, I'm having some lag there. There's the first 1,200 points.
It went up by 1.
And it went up a little bit, right? But again, do you see asymptotic behavior here or not? How far am I going to need to go out? I'm doing this sum, right? I've only gone 1,200 out. How many more do I have to go? Infinitely many, right? So even though it looks like this is growing really slow and maybe it's like asymptotically approach something, I'm only at 1,200 points. Like I have an infinite number to go. So I think from that picture, there's an argument to be made that this thing does not look like it's converging. This looks like this is getting bigger and bigger, just slowly, very slowly, right? Still an open question, all right? What's more important here is for you to understand how I'm building this new sequence, right? My original sequence, and I'm building a new sequence off of it. Let me back it up. Go back. Let's look at 1 over n cubed. 1 over n cubed. All right, so 1 over n cubed looks like this. And it looks like 1 over, let's see, 1 over 1 is 1, right? And then 1 over 2 cubed is 1/8. 1 over 3 cubed is 1/27th, right? That's our sequence. And now let's start adding them up. So you've got 1, and then now add these two up. 9/8, and then whatever, who cares, right? But we have this new sequence. That's going to be the blue one. And look at this right here. Let me take you out the first 100 points. What do you think of that? Does that look more asymptotic to you? Yeah. That looks more asymptotic to me as well. Yeah. It's like, I don't know, I can't go any more than that. There's like no pitch to that curve at all really anymore, right? It's like it went up and then just like flattened out. I'm at 1.20 right now on the blue one, and I've gone 100 points. Let me go 1,200 points. And let's just keep an eye on that number. Oh, wow. My computer has stopped changing because what's happening is there is stuff being added, but the decimals that are changing are way out here. You know, it's like the first few decimals are fixed now. They're never going to change, no matter how much further I go out. The only thing that changes now are the things out there. The decimals are way out there. So that looks really convergent, doesn't it? Yeah. So sometimes it converges, sometimes it looks like it doesn't. And so what we are tasked with here is trying to figure out which series converge and which ones don't. Right? That's what we need to do. Okay, the big challenge, right? We were seeing that some series sum to be infinite and others do not. They seem to converge to a number, right? Like that last one, what was it, 1.20 something? It seemed to converge to a number. But we cannot tell by just looking at the sequence, right? We can't just look at the sequence and tell. This is the hard part about this whole idea. In order to do this, we're going to have to develop these things called the series tests, which is a formula sheet that's on Canvas, right? Should we look at it?
Yeah. Out of curiosity, will that be useful?
What? Oh, yeah. Where's my series test? Yeah, series test. Where is it? I really don't want to have to log in. There it is. Here we go. This is it. Summary of the convergence and divergence tests for series. These are all the different tests that we need to know how to implement. We have the n-term test, the geometric series, the p-series, the integral test, the comparison test, the ratio test, the root test, the alternating series test, and the absolute convergence test.
It sounds more overwhelming when you say it quickly like that.
It sounds, when I go fast like that? Each test describes what series you're allowed to use it on, because these tests are not universal. That some of them only apply for certain looking series, like you have to have an alternating series, or you have to have this or that. So each series tells you exactly what type of series you have to be looking at. This describes kind of how the test works. And then this describes like some comments like, oh yeah, remember if this happens, that tells you nothing, the test fails. And so we are going to have to get intimately familiar with this sheet of tests. And yes, you're allowed to use that on the test, on the exam, and you are welcome. Yeah. Yeah, because there are some Cal 2 classes that you could take that are here on this campus or on the university where you have to just know these tests. You just have to know them. That's Cal 2, all right? When I learned it, that's the way I had to learn all these tests. I had to know how to use them. And there's an argument to be made that that's better because it really forces you to learn them. Because then you're not sitting there going, okay, what test am I going to use? You know, it's more of like, I understand what's going on. But I'm not making that argument, okay, because I'm letting you use it. Yeah, well, yeah, I don't know if you should think, I'm probably going to get really, math purgatory, that's going to be real. They're like, we don't care about your errors, but you let them use this. No. All right, some notation and language. All right, so what we're seeing is that some series, I've done that. Here we go, language. Let's get some notation out of the way, right? We need to get some language in order here. So if you look at this, right, this is the infinite series. N equals 1 to infinity means you start adding up the terms of the sequence, the first one, second one, third one, you go forever, right? Now, that is different than this thing called the nth partial sum. So remember how I was making that, I made up a new sequence? And what I was doing, I started adding the pieces of the other sequence? Yeah. Okay, what I'm doing there is I'm creating this sequence S sub n. So S sub n, capital S sub n, what it is it's the sum starting at k equals 1 and stopping at n of the sequence. So what it does is S sub n basically adds up the first n parts of a sequence. I didn't do anything formal, I just like verbally, but now I'm formally giving it to you. So capital S sub 1, so if somebody gives you a sequence, right? Somebody hands you a sequence. I'm going to do an example over here. Let's do an easy example. A sub n equals n. That's a real easy one to work with, right? I give you that sequence. Now I ask you to create this new sequence. S sub 1 would be what? Well, should we write this sequence out? This is 1, 2, 3, 4, right? Like that? So that's this sequence. What's S sub 1? 1. What's S sub 2? What's S sub 2? 3, right? It's these two added together. What's S sub 3? First 3 together. S sub 4? 10, and so on and so forth, right? This is a new sequence, isn't it? This is a new sequence. This is the sequence 1, 3, 6, 10, ... and it keeps going, right? That's a new sequence generated from that sequence, and what it is these partial sums. It's not the entire infinite sum, it's parts of them, and it just keeps getting one, we add one more part each time. So S sub 1, S sub 2, S sub 3, S sub 4, and then you get down to S sub n, and that is you stop at the nth one. I say here, again, notice that this creates a new sequence, right? That's a new sequence. And our question is whether or not that sequence converges or not. Yes?
So, correct me if I'm wrong, but is the whole point of that to like kind of accelerate the existing process to see it faster?
No, the point of this sequence is that each one of these numbers represents the sum of those. Every time I go out one here, I'm adding one more of those, right? So what if you look at this sequence, and what if when you're looking at this one, it stops changing or this converges to a number? What if this converges to a number, this sequence? What if you can show that it converges to a number? What does it mean about that sum?
That one would have been.
That converges, the sum converges, right? Not that this sequence converges, but that the sum converges. So we start with that sequence, then we create this new sequence, which is a bunch of partial sums, and we're trying to see, does this go somewhere? If this goes somewhere to a number, then that infinite series adding things up converges. Yep.
Is the series a type of sequence? Or did I say that backwards?
No, a series is a sum.
Oh, okay.
Yeah, a series is a sum of things. All right, so the question becomes, this new sequence, right? Does it converge or not? Right, that's the question. So what we will do is we will take the limit as n goes to infinity of this sequence, right? That's how we figure out if a sequence converges. We just take the limit as n goes to infinity. Problem. We have a huge problem though. We have the formula for this sequence, right? Do we have a formula for this sequence? Not generally. It's very difficult, generally, to start here and come up with a new formula for this. It's not. It depends on this. This dictates whether or not this has a formula or not. Well, not easily. Not easily. So there's no easy, like, general way to go from that sequence, that sequence, and then create this new sequence and have a formula for this. There's not an easy way to do it. But if we could, if we had a formula for this, then all we'd have to do is take the limit as n goes to infinity, right? So that is our big freaking question, all right? This right here is the sequence S sub n. But what is the formula for it, right? What is the formula for it? We know the formula for that, but we don't know the formula for that. If we had that formula, then that's all we do. Let n go to infinity. That's it. And then, hopefully L'Hopital or something, I don't know, we get the answer, right? Okay. That's me just saying, in general, it's difficult to determine S because it's hard to come up with a formula. Let's clarify. I think we're okay here. Test for divergence. Okay, the first test on your sheets. The very first test on that sheet I just showed you. It's called the test for divergence. And this is the easiest test. Out of all the tests, this is the easiest one. Here's what the test says. If you're given a series, you want to add a bunch of things up? It's really hard to tell, right, whether or not it converges or diverges. Generally, it's hard to tell. But for certain series, we can do a very quick check and show it diverges. And here's the check. If you're looking at a series and you then go just look at the sequence. Forget that we're adding anything up. Just go look at the sequence. Take the limit of that sequence. If that limit goes to something other than 0, this sum diverges. That's it. And I think it's kind of logical if you think about it. If I'm asking you to add up a bunch of things, right? And these things are not going to 0, that means they're headed somewhere else, like maybe these numbers in here are getting closer to 1, let's say. Then that's really like adding up 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 forever, which would become infinite, right? The only time we're ever going to get convergence, the only time we will ever get convergence is when these things go to 0. If the sequence goes to 0, we can get convergence. But if it goes to somewhere other than 0, we definitely don't have it and we have divergence. Let's do an example. Show that these diverge. All right, this is a series, right? N equals 1 to infinity. Sum n equals 1 to infinity. Here's the sequence that I'm adding up, right? I'm adding all those little pieces together. What I'm going to do is I'm going to take just this first. I'm going to do the nth term test. I'm letting you know that. The reason I'm letting you know that is because as we proceed through this chapter, what's going to happen is you're going to learn all these tests. And when you're doing the problems, you're going to try a test and it's probably maybe not going to work. So then you move on to the next test. And then you try that and we say, oh crap, that didn't work either. Let me try this other test. So in your writing, in your presentation of your work to me, I need to know what you're doing. You can't just assume I'm going to look at it and know what you're doing. So I am letting you know I'm about to use the nth term test. So I'm going to take the limit as n goes to infinity of that sequence. And now we are back in the previous, we are now in the previous section, 8.1. This was your homework assignment, right? What we did in class today a little bit. What is that limit? You get infinity over infinity?
Yeah.
So L'Hopital?
Yeah.
You would have to switch to a function of x and then go back, but I said we're not doing that anymore, so we're just going to do L'Hopital here. And we get, what, 5 over 1? Which is 5, right? That goes to 5. What does that tell you? Yeah, so this is not 0, right? The theorem says if you take the limit of the sequence and you get something other than 0, you can say now, therefore, 3 dots for therefore this series diverges. Therefore, the series diverges.
So the sequence converges to 5, but the series diverges.
That's right. The sequence converged to a number other than 0, which means that the series must diverge. It's like these numbers in here are getting closer and closer to 5. So what happens if you start adding up numbers that are like closer and closer to 5? It's going to look a lot like 5 plus 5 plus 5 plus 5 plus 5 plus 5 forever, right? Which has become infinite. It's going to diverge. Okay? What about the next one? Does this converge or diverge? Same idea, right? Take the sequence in here, run the nth term test, take the limit as n goes to infinity of sine of n. All right, what does that limit do? That's right, so that limit does not exist. Okay? This limit does not exist, right? What does the nth term test say? It has to
Equal 0.
well, careful. The test says that if this does not equal 0, then it diverges. Does this not equal 0? That does not equal 0, right? Does not exist does not equal 0. So since that does not equal 0, we can say, therefore, the series, right, diverges. Is everybody okay? Yes? Let's do this one. Same idea. Let's take the limit. We're doing the nth term test. N goes to infinity of inverse tangent of n. So if I let n go to infinity, we have to think about what is inverse tangent of infinity. I think we've done this before with integrals before, something like this. Inverse tangent of infinity is really saying, where does your tangent function become infinite? At what angle? Pi over 2. Pi over 2. You have to go back to the graph of tangent. Looks like this. Right, that's a graph of tangent, and here at pi over 2, it takes off to infinity. So the inverse tangent of infinity would be the pi over 2. Why am I not looking at one of these over here? Because remember, tangent is period, it keeps on repeating itself. Why am I not looking over here? Why am I only looking here? Right? What? Because I'm looking at the inverse tangent, and the inverse tangent has a restricted domain that you're only looking between here and here. So between negative pi over 2 and pi over 2 is where I'm looking. So this goes to pi over 2, which is not equal to 0. Therefore, we get divergence. Understand?
When you say it goes to pi over 2, would it have been acceptable to use the arrow or not?
Yes. You could have said that goes to pi over 2. That's okay. I mean, normally I would write this, that with an arrow to pi over 2. If you do the limit, then you technically write equals. Okay, I've got another one for you. Ready? Pay attention. This one's a good one. This one's not on my notes here. How about this? Sum n equals 1 to infinity 1 over n. Let's try the nth term test. That's the only test we have right now, right? That's the only test we have. So let's try it. The nth term. So I take the limit as n goes to infinity of 1 over n. And that equals 0.
We just know that it doesn't diverge.
All we know right now is nothing.
Yeah, it doesn't diverge.
No, we're not saying it doesn't diverge.
I think the test did say that, right? Oh.
So this is a critical thing to understand about the test. Okay? It says that if you get 0, you diverge. I mean, I just said the test wrong. If you don't get 0, right, it diverges. Does it tell you what happens if you get 0? No. Okay, so if you go to the sheet, the notes, it's the very first test here. And it says here that the series will diverge if that limit doesn't go to 0. But if the limit does go to 0, the test is inconclusive. All right? That means we don't know what happens. This is like a COVID test. I used to say pregnancy test, but it started to piss people off. Okay, we can use COVID now. This is like a COVID test where you take the test and then the control line shows up, right? Or doesn't show up. You know what I'm talking about? You have the 2 lines.
Yeah.
Like, you know, and if this one shows up, then the test worked, right? And then if this one shows up, then you've got COVID or something like that. But like if nothing shows up, what does that mean? That test is a bad test, right? You need to go take another test, or you need to do another test, right? Go get a different brand or something, right? So when we get 0 on this nth term test, it's like a failed COVID test. It's like a bad test. And so we just need to move on to another test. The biggest mistake students make when they're using this test is they say, oh, it's 0. If it's not 0, it diverges, so it converges. And that's not the way the test works, okay? So right now, what do we know? Nothing, okay? So we don't have an answer, and I can't answer this yet, all right? That'll be P, or you could look at it as harmonic or P, yeah. We haven't talked about it. All right, so 5 minutes. You know what? This is probably just a good place to stop. I plan on either today or tomorrow to send you all something in terms of getting ready for the test. So please check your email. Be looking for something in terms of some guidance review for the test, all right? It'll cover everything up through what we just finished with. Will not include this geometric series stuff. But next Tuesday, I'm going to get into geometric series. And this train is going to continue to move down the tracks. So while you're studying, you need to also keep up with what's going on in here.
So is that going to go towards the final?
What is?
Like stuff on Tuesday and beyond?
Yeah. Yeah. The final, like I told you all earlier in the semester, the final is almost exclusively Chapter 8. Because there's enough material here for that.
So it's not everything.
Not the whole semester, no.
Are we going to have hyperbolics?
Not even in Cal 3. No. Okay, everyone, have a good weekend. I'll hang out for a few. Actually, I'm going to go to my office, but if anyone has, I've got to cut out today around 2. Just so you'll know, if anyone's coming by, 2 o'clock, I got to bail. So I'll be down there right now, but at 2, I'm gone.